Good morning, all of you. So now come to know that last class I taught you when you introduce the current carrying conductor in magnetic field, like how the force is exerting on a current carrying conductor when it is placed in the magnetic field. Correct? So now if it comes to here, we have been identified the direction of force and as well as direction of current and direction of magnetic field with the help of Fleming's left hand thumb rule. So this is what we used to call as a Fleming's left hand thumb rule. All the three fingers, as I told you, when the force is maximum, guys, can anybody tell me when the force is maximum? When the magnetic field and as well as the direction of current will be perpendicular to each other. So all the three things, the three parameters, if you notice it, all must be in perpendicular to each other. That is what we used to say a Fleming's left hand thumb rule. So now this finger, the middle finger, is indicating what, guys? Please speak, because if you only you can understand.
Current.
This is the middle finger which will always indicates the direction of current, and this finger what we used to call? This finger,
Magnetic field.
the finger which we used to call as a magnetic field, and this finger we used to call as displacement. Force we used to call as. So now if you notice it here, with the help of same thing, as I told you, we are studying these three things. So magnetic field, this finger, and this finger, direction of current, and this finger, forefinger. So forefinger, if you'll notice it, center finger, if you'll notice it, what is this? Direction of current. And forefinger, if you'll notice it, then what it is? It is indicating that index finger, if you're indicating, it is direction of magnetic field, and this finger, thumb, is always indicating the force exerting. So now with the help of this only, now today's class we are going to study electric motor. So now this electric motor will classifying into three parts. Then the three parts individually will study. First of all, electric motor, what it is and what it will do, and later what is the working principle of electric motor. Next one, what is the construction of electric motor, and as well as last, how it is working. So this is the easiest one, but the thing is a lot of things you need to discuss and you need to work. So that is why little carefully you have to understand. So first of all, as I told you, we are going to study what it is now. Electric motor, yes or no? So now what do you mean by electric motor? First, anybody, what do you mean by electric motor? You might be noticing in our home you might be having washing machine, mixer grinders, even electric cars, lot of things you might be notice. Even nowadays electric scooters are coming everywhere. So now what do you mean by this? Even electric motors you used to see in our home, even to pump the water, or if you have a toy cars and all, you might be noticing. So what do you mean by electric motor? Anybody? Please respond. So remember, electric motor is a device, is a machine or a pump or something which converts electrical energy into mechanical energy. That is the first thing which you need to understand. What do you mean by electric motor? Electric motor is a device which converts electrical energy into mechanical energy. Means motion, movement it will come. So as we know already, mechanical energy means what? Either it is potential energy and kinetic energy. So the sum of potential plus kinetic energy only we used to call it as mechanical energy. So if you notice it, every motor, like which is electric motor I'm saying you. So every motor is a device which will convert electrical energy into mechanical energy. So here every motor has a shaft, or we can say spindle, means like a hand, understanding our hand. So it will rotate continuously when current is passed into it. So this rotation of its shaft, understand, which is used to drive the various types of machines in home and as well as industries everywhere. So this electric motor only we are using in washing machines, refrigerators, mixers, grinders, electric cars, and many applications, many appliances in industries and as well as home. It is working with this electric motors. So as I told you once again, electric motor is having a shaft. Shaft means like a handle, understanding? A spindle, we can say shaft or spindle, which will rotate continuously when a current is passing through that. So because of this rotation of its shaft, it is used to run, it is used to drive a various types of machines. That is only ways to called as electric motors. So as I told you, these electric motors we can use in many places in our home. Wherever you are using grinders, mixers, and mixie, washing machine, refrigerators, electric cars, electric scooters, everywhere. The electric wheel, if you notice it, electric car, each wheel of this electric car is turned by electric motor only. So everywhere the electrical energy is converting into mechanical energy so that the displacement of the car will take place. Every wheel of electric car is motor, so that motor will convert electrical energy into mechanical energy. So now, if you notice it again, these motors is converting into two types. So one is a common electric motor, like a simple, which we are using in a toy cars or else any kind of science projects and all. A common electric motor works on a direct current, means a fixed voltage it will be having, like a batteries and all, it will work. Whatever the motor which will work with the batteries, then that is called as DC motors. So means a direct current motor, a motor which will works with the direct current motor. So that electric motor which we are going to discuss now is actually a DC motor, which we are studying in the chapter. They're saying electric motor, but it is actually a DC motor which will works with a direct current, which will works on direct current. So we're having two types of current, first of all. That is what? Direct current, and another one is AC current called as alternative current, means flexibilities will be there. High voltage, low voltage, like that is to come. So whatever the motors which will work with the fixed batteries or cells, whatever it is, they are called as direct current. So no fluctuations in the currents, high and low. So they are called as DC motors. Like if you take mixer grinders, washing machines, and etc., they are all work with sometimes more and sometimes less. You can see our home, sometimes high voltage, sometimes low voltage. And these are called as AC motors, which will work with alternative current. But we are studying in the chapter, actually we are studying DC motor, but we will say as a electric motor is a common thing. So that is what. So DC motor means a direct current motor, AC motor means alternative current motor. So that is what the motors are classified into two types. So now first of all, you have to remember that electric motor is a device which will convert electrical energy into mechanical energy. It is having a shaft. You understand? Or spindle ways to say, like I will show you while I'm teaching. So that spindle which will rotate continuously, so that with the help of that, when the current is passed through that, we can operate different kind of machines. That is only ways to called as electric motor. Now, this is what electric motor is over. Next, principle of motor or electric motor. Very, very important one. So as we notice it, electric motor utilizes the magnetic effect of current. That is all of you remember. So here, like as we discussed before, a force exerting by a magnetic field when a current carrying conductor is placed in it. So the same thing here we are using. If you'll notice the principle of a motor, electric motor, everything, it will utilizes the magnetic effect of currents. So this motor works on the principle that when a rectangular coil, for example, let me go to here and you can observe that. So this is what in detail diagram of inside the electric motor, how it will be present. So now here you are finding one rectangular coil. Can you able to notice it? What is that rectangular coil naming? Anybody? Try to speak. Communicate. What is that rectangular coil here? You're noticing here the rectangular coil is ABCD. Yes or no? ABCD. So this is only ways to called as rectangular coil. Here they mentioned clearly. You can see ABCD. So this is what the perfect picture of a DC motor, or we should not say DC electric motor, we should say simply a motor. So first of all, this is what, if you notice it, others also you can just inform them. So this is what electric motor, everybody should learn this. So now if you notice it here, this motor works on the principle that when a rectangular coil is placed in a magnetic field. See last experiment, which coil, which one we have placed, anybody? Arvind? We have been placed a straight conductor, yes or no? So straight conductor is placed between the horseshoe magnet. Yes guys, please respond. Nobody is responding. Yeah, but here we cannot keep a straight conductor. Why straight conductor? Either it will be moving towards the right. My right hand is this side, so that I am saying this side right. But you are watching me opposite to me, so that your right hand is right side, your left hand is left side. So we have been placed a straight conductor between a horseshoe magnet, so that based upon the direction of current, it is moving either towards the right or towards the left. But here we want to rotate the shaft. Shaft means some kind of a spindle handle which needs to continuously rotate in some direction, so that it will be operate the machine. So that to rotate it, we are taking a horseshoe magnet like this. Backside you are not noticing that image, horseshoe magnet. So middle they have been placed a rectangular coil, name as what guys? What is a rectangular coil? Called as ABCD. So now here you might be notice the magnet. This is the North Pole and this is the South Pole. So this is which magnet actually? This is the horseshoe magnet or magnet. Understand everyone? Kevin, Padmarshini. So that is what you will see. So this is the horseshoe magnet. So I have been placed rectangular coil ABCD. So now what is the working principle? A motor works on the principle that which coil we have been placed? A rectangular coil, understanding, placed in a magnetic field. Then when the current is passed through that, a force act on the coil which will rotate it continuously. So when ABCD coil is rotating, the shaft which is attached to it also will rotate. So that is the way the electric energy is supplied to the motor, which is converting into mechanical energy of rotation. So now that is what you need to understand. So what is the working principle, guys? Anybody? So the working principle means what? When a rectangular coil ABCD is placed where? Placed in a magnetic field and current is passed through that because of the force acting on the coil which rotates continuously. So this is only ways to called as working principle or principle of motor. So when rectangular coil is rotating, a shaft which is attached to that. So if you open the picture, all of you page number, you have textbook correct guys? Please respond and see. So that shaft, if you notice it, the axle they have been mentioned there. So that is only ways to called as shaft. So the shaft also will start rotating because of this rectangular ABCD coil is rotating, so that the some missions and all will be operating with the help of that. That is what we used to called as a working principle or principle of electric motor. Have you understand guys? Please respond. Yes. Yeah, I will show you. Yeah. So now if you have DC motors, you can take it, or else 1 minute I will show you. So this is what the shaft means, like a handle which we can insert the fan. Have you noticed it guys? A fan we can insert it. That is only ways to called as a shaft. You might be having a DC motor, anybody you can check it. Recently have been used correct for running the things. So that is only ways to called as shaft. Here, have you seen this like a extending part front? This is only ways to called as shaft. You might be notice it. This is what the part. If you notice it, these are the parts of electric motor. So here the shaft means the part which is coming front. This is what. So DC motors, you can notice it. I will show you the DC motors. So DC motor, if you'll see the front part where we'll insert the fan and all. Have you seen guys? This is This is what we used to call it as shaft. Understand everybody? This is the front part which is extending. This is only we used to call it as shaft. So this is the shaft which is operate. So this is what you can see DC motor, which we are presently discussing. This is what inside the picture, how it will be present. So this is only we used to call it as shaft. So, and you might be notice it here, this light yellow color and light blue color. This is what have you seen, guys? Please respond. This is input current and output current. Means in intake and current is taking going inside and coming outside here. And have you noticed this orange color rings here? Please respond, everybody. Orange color rings. Nobody is answering. Orange color rings. Can you see here, guys?
Yes, sir.
Yeah, that is only we used to call it as split rings or armature. I will say you now. So what is the importance of that? So this is what we used to call it as shaft. So what is the working principle of electric motor? Anybody? Please speak. Nitinath, Kevin. What is the principle of electric motor?
Converts electrical energy to mechanical energy.
No, that is the name. What is electric motor means? Which will convert electrical energy into mechanical energy. Principle I am asking. Principle of motor, if you take, a motor works on the principle that when a rectangular coil, what is the name? ABCD.
Rectangular coil ABCD used with a magnetic effect of current.
A magnetic field and a current is passed
when
through
it
that.
rotates,
A force acting on the coil which
spindle or
rotates
shaft.
continuously. Understanding? So when the coil rotates, the shaft which is attached to that is also will start rotates. So that is what the electric energy supplied to the motor is converting into the mechanical energy of the rotation. So this shaft, that handle, also we can say called as spindle. Understanding? So that is what the principle of motor. Have you understand, everybody? Please respond. Yes. So now if you notice it, so this is what the two things you have to notice. Next, we are going to study construction of motor. Okay. So this is what a DC motor internal structure, if you notice it. So construction, let us see what is the things that you are finding here. Let me speak, everybody. Try to communicate and tell me what are the things you are noticing in this. Please respond. What rectangular coil you are noticing? So what is the rectangular coil name? Anybody?
ABCD.
ABCD. That is first you have to remember, and that coil is insulated copper wire. Okay, guys. So now an electric motor consists of first thing, construction of motor. Very, very important. Every part you should know, every part we have importance. So kindly focus it very carefully. I will show you very slowly, and each and every part is very important because exam they will ask you that one. So if we'll take this electric motor, which consists of rectangular coil. What is a rectangular coil? You are noticing the picture. You have to speak. What is a rectangular coil? A, B, C, D. Understand, everybody? So that is what we used to call it as rectangular coil of insulated copper wire, which is mounted or settled, placed between the curved poles of horseshoe type permanent magnet, which we used to mention the magnet is capital M in such a way that it can rotate freely between the north and south pole of a shaft. Understanding? So this, if you'll notice, that is what we used to, it needs to rotate freely between the north pole and south pole. Have you noticed it, guys? So there is no touch between the poles of a horseshoe magnet. So if this is the horseshoe magnet, so I have been placed a rectangular coil which will rotate freely. How it will rotate? A long cylinder. Here if you'll see, here I have been attached as some kind of a cylindrical kind of rod. That is what we used to call it as shaft. Understanding? So that when the rectangular coil is rotating freely, so that the shaft also will rotate freely. Do you understand, everybody? Please speak. So that is what we used to call it as electric motor, the first part. So every electric motor, what we are doing, a rectangular coil, we have been mounted between the curved poles of horseshoe magnet, horseshoe permanent, understand, type of permanent magnet, in such a way that it can rotate freely between the north pole and south pole on a shaft. So what do you mean by shaft here? So textbook, if you'll see, one rod is coming front. Have you noticed it, guys? Please respond. Yes? Yes? A rod is coming front. Yes, please respond. In the picture, it is not showing, but in the textbook, one axle they mentioned. Have you seen, guys? Axle textbook they're mentioning as an axle. Yes, that axle only is to called as shaft. Okay. So now this is a shaft is a long cylindrical rotating rod which is at the center of the coil. Understand? So which has not been in this picture. I am not showing here. So it will be in the center of this coil, rectangular ABCD coil. So which will pass through this in between these rings, or we can say the commutators. Here it will be one axle will be present. So that is only ways to called as a shaft. Okay, guys. So now which will rotate freely because when the ABCD coil, rectangular coil is rotating in the freely in between the two poles of a horseshoe magnet. That is what is the first setup which you need to remember. So now the second thing, if you'll notice it, then what you are seeing, guys. So till ABCD coil and magnet you have been studying. Now if you'll see, the rectangular coil is having two sides. You might be notice it. One is AB, another one is CD. Have you seen, guys? Please respond. Everyone?
Yes, sir.
So one side is called as, I will highlight it here, you can see. So one side is called as AB. Kavya, have you understand? This is the AB side and this is the DC side. Now you tell me, let me speak, who will speak. So AB and CD are perpendicularly to the direction of magnetism, or they are parallel to the direction of magnetism. Let me speak, who will say. AB and CD, is it they are parallel to the direction of magnetism or perpendicular to the direction of magnetism? Kindly speak.
Perpendicular, sir.
Perpendicular. Yes, correct or not? Because the direction of magnetism is acting which? North pole to south pole. Like this it is acting. You can keep your fingers on my screen, you can keep. Understand? You can understand. Like your laptop, whatever you are seeing. Direction of magnetism is acting like this and the rectangular coil is placed like this. So why we are placing perpendicular here? Because when the both are perpendicularly each other only, the force will be maximum or minimum. When the force is maximum, when they place
Perpendicular, sir.
yes or no? Nitish, have you understand? So that is the reason you have to understand AB and as well as CD, we have to place it in such a way that they are perpendicular. Do you understand, everybody? So the sides of AB and CD of the coil, they are kept perpendicularly to the direction of magnetic field, understanding, between the poles of a magnet. So the magnetic field is acting in this direction, the coil is kept like this direction. So this is AB and this is CD. Have you clear, everybody? Please respond. Yes. So why we are doing this one? Because the maximum magnetic force is exerted on the current carrying conductor. That is what a side AB and as well as CD of the coil. So that is why the reason why we are placing perpendicularly the AB and as well as CD, because you can write the answer, because I will speak and you have to note it down, because exam, everything they will ask you. What they will ask, we don't know. That is the reason. Okay. So now what is happening? AB and as well as CD coil. So why we are placing perpendicularly each other? Because the maximum magnetic force is exerting on AB and CD. Only they kept perpendicularly each other. So as I told you last offline class, as we know, the magnetic forces depend on three factors or four factors. What is that factors? One is magnetic field, and next one is what? Current, and as well as length of the conductor, and as well as last one is what, guys? Sine theta. Understanding? So sine theta means theta is equals to angle. So if theta will become 0 when parallel, so that no force is exerting. So force also will become 0 because sine 0 is 0. Now if sine theta, sine 90 it will become, means in the sense of theta is equals to 90. As we know, sine 90 is equals to 1. So that then the force will become B into I into L. So L means what here, guys? Arvind, L means what? Length of the conductor. Yes. So length of the conductor. So length of the conductor means here more number of rectangular coils, ABCD. You might be notice it inside the electric motor. More number of coil it has been made it as a rectangular, because to increase the strength of the magnetism. So that is what the force exerting. So BIL is the factors. B means what, guys? magnetic field. Those who don't know, you can understand. And I means what? Amount of current, and as well as L means length of the conductor. So that is why always you have to place perpendicularly each other. Please call to others, Rari. So now this is what you have to understand, guys. Still here, any doubt? Anybody please speak. If you want, again, I will say that. Now, if you notice it, why we are placing perpendicularly AB and CD sides? Because the maximum magnetic force is exerted on the current carrying sides AB and CD of the coil. That is the thing. Next, in the picture, if you notice it, you might be noticed a commutator, or we can say split rings. Have you seen it, guys? Everybody, you might be noticed it commutator or commutators, or we can say split rings. We used to call it as what we used to call it? Split rings. Understand? Your textbook, they may be mentioned as split rings, or here we can say as called as commutators. So, which will rotate with the coil. That is what we used to call it as commutator. Okay. So now, once again, I'm saying, Kavya, ABCD rectangular coil, side AB and as well as CD must place perpendicularly to the direction of magnetic field, because when they are perpendicularly each other, remember when the angle between them is 90 degrees, then only maximum magnetic force will be exerting on the coil. That is the reason why always will place. This is the direction of magnetic field. You might be notice it, North Pole to South Pole, but the conductor is placed perpendicularly to that. This is what we used to say perpendicular. So why we are placing perpendicular? When the angle between them is 90 degrees, then the maximum force is exerting on the coil. That is the reason why we are placing perpendicular. Okay, Kavya? So now if you notice it, guys, commutator, or also we can call it as what? What we used to call it, guys? Split rings we used to call it as. Understand, everybody? So now these split rings will rotate with the help of rectangular coil. Along with the rectangular coil, you can see. So these split rings, middle, have you noticed it, guys? Is it connected or broken into two pieces? Have you checked it? Middle, there is no connection. This is one half C part, half ring, and this is another half ring. Have you seen, guys? That is why these are called as commutators, or we used to call it as a split ring. So these split rings it is a device which will reverse us the direction of current through a circuit. That is only we used to call it as split ring or commutator. Okay. So what do you mean by commutator? Means which will reverse the direction of current. Sir, how it is reversed, sir? Let me take. So the two ends of the coil which are welded or soldered permanently with two kinds of half rings. That half rings only we used to call it as. What is the name of these half rings? Everybody see. What is the name of these half rings? One is X and another one is what? Y. Can you understand, everybody? One half ring name called as X, another half ring name called as Y. So now this is not attached to the, all of you observe, this is not attached to the point P and point Q. This is another thing. Carbon brush which is fixed here. Understand, everybody? Carbon brushes, I will say you what is important. Carbon brushes are fixed here, but this X and Y split rings are not attached to the carbon brushes. Do you understand, everybody? They are attached to the rectangular coil. Understand? They have been welded to the rectangular coil. Okay. So now here you notice it. This is what rectangular coil. So for that end, this one half split ring is welded, and this side, when this rectangular coil is coming, so this side it has been welded. So if you imagine, this is the carbon brush, my phone is the carbon brush, you understand, everybody? So it's no connection between, this is the first half split ring. If you imagine my hand, now it is connected to the rectangular coil, it is not attached to the carbon brush. So only it will come and will touch the carbon brush to take the current and as well as to leave the current out from the rectangular coil. That is the only thing. Understand? So the split rings which will change the direction of current. I will say you when explaining the working, I will explain you what it is. So split rings, what it is, guys? It is a device which will reverse the current, which will reverses the direction of current through a circuit. That is only we used to call as commutator or split rings. So these two split rings, which we used to call as X and Y, which are soldered or welded permanently to the two half rings X and Y of a commutator. So these commutator is a copper ring which will split into two parts, like half ring plus half ring, like this it is present. So this half ring we used to call it as X, which is attached to the AB side rectangular coil, which is Y, which is attached to the next CD side rectangular coil. So this is the two parts which are insulated from one another, and these are only we used to call as commutators. So these are mounted on the shaft of the motor. Means middle, if you imagine this is the shaft, then these commutator rings will be like this. So they will be mounted with the help of rectangular coil. When the rectangular coil is rotating, so middle shaft will be there. So that shaft is covered with these commutator rings, so that the rings, when the rings also will rotate, so that the shaft also will keep on rotating. That is what you have to remember. So this commutator also is a copper ring which is split into two parts called as X and Y. Now, if you notice it, guys, at the end A of the coil, which we are welding, which part? End A we are welding X commutator, and end D we are welding dy commutator. That is what you have to remember it. Okay, guys, everybody please speak. So that is what we used to call it as commutator. What is the importance of commutator, Padmarshini? Commutators will reverse the current. That is the thing. Understand? So commutators will reverse the current in the given electric coil, ABCD rectangular coil. They will reverse the current. That is the importance of commutators. So we are having two commutators which is attached to the AB side one commutator and the D point, CD point another commutator. So now if you see, the function of these commutator rings is only one thing, that is